So yesterday you did the 5-number summary. So that's going to be the basis for everything today. All right, so if you weren't here yesterday, we kind of went over how to get all these values already. And today was only going to be about how to graph those. So let's just use the first one as a little review. And let's do the 5-number summary. And then we'll do the graph and probably one more example. And then you'll be off and running for the rest of the period, more or less, to get everything done. All right, so step one would be yeah, everything in order. And depending where you go, some people do this least to greatest, some people do greatest to least. It doesn't make a difference except it's in order. You'll get the same answer regardless. 62, 62, 6, 66, and then 68, 78, 80, and 83. Now, if you fail to do this first step wrong, everything will be wrong after. So believe it or not, on this algebra problem, statistics problem, the number one mistake is, did you get all the numbers? So you can always double check it and count them up, 1, 2, 3, 4, 5, 6, 7, 8, and make sure you have the same that you reorder. 1, 2, 3, 4, 5, 6, 7, 8. Okay. All right, the min and the max, probably the easiest one. So we got 56 and 83. Okay. And the 2, 3, and 4, the first, second, and third quartiles, those are all medians. Okay. So we find the median of the whole data set. So you find the middle of the two middle numbers here. In that case would be the middle of 66 and 68 is 67. Right? Then you find the middle of just the first half. And you find the middle of the second half. So it's your Q1 and your Q3. Now, as you saw yesterday, the only thing you have to change up from problem to problem is if there is an odd number of data points or an even number of data points, it's slightly different. So here it's an even number, right? So the first half is just the Q1, the second half is the Q3, but like on the next one, there's actually 11 data points and it's slightly different. We'll look at that in a second. So know that there is a small difference depending on if there's an even or odd number. So the first, median of the first Q would just be 62 since they're both 62, right? The median here for the Q3, what's the middle of 78 and 80? 79. Okay. Of course, for any one of these, you could technically add them up and divide by 2, but if you can figure out 79 is the middle of 78 and 80, you don't need to do that. All right, so we have, that's basically your homework from last night. We got the min, max, and 3 medians. Let's see here. What is the IQR? So we have Q3 minus Q1. That's called the interquartile range. And what would that equal here? 17. And then we have the range. And that would equal 7. So we have those two values. How far is it from 56 to 83? It's 27. How far is 62 from 79? It's 17. Okay. So those are the other values that you'll be graphing, so to speak, and I'll show you right now. Now, besides the idea that you have to have them in the right order, when you go down to graph it, you'll be given some sort of number line that's not numbered. So it doesn't give you like 56, 50. So you have to kind of figure out, well, what should I count by? So if you started with 56 and you need to end with 83 because that's the min and the max, do you have enough room or enough of these tick marks to get from 56 to 83 by counting by ones? Yeah, if not, then you need to count by twos. And the numbers are really big, you might need to count by five. So that's going to change from problem to problem, depending on how far apart the min and the max are. Now the range will kind of help you out there. So if we know they're 27 apart, you just have to count these marks, and if there's 27 of them, then you know they'll fit. If there's fewer than 27, you know, well, it won't fit by counting by ones. So the range will help you figure out the scale here. So we figured out we have to count by twos. So let's start with 56. And just, unless you can write real small, I recommend just counting every other. So 64, 68, 72. Remember that the look of your graph does matter. We're going up to, I didn't even go that far, but it does matter. If it's neater, more people are likely to look at it and pay attention to it. If it's just, you know, thrown together sloppy, it's going to be a reflection of your understanding of what you're doing. So if you don't put time into making it look good, whether the information is correct or not, people will be less likely to believe it because it's all sloppy. All right. The min and the max. Let's graph those first. Those are either dots, actually almost always dots. You just put dots for those. So 56, you can put a dot. Use red. And then you find 83. So it's 82, 83 would be right here. Your quartiles, all three of them, includes the median, are just vertical lines. Vertical lines. So you put a vertical line at 62, 60, 62. And then we got a vertical line at 67. And then another vertical line for the third quartile at 79. You put a horizontal line that represents the IQR. So from Q1 to Q3. Like that. And then you also put some lines to connect the minimum to the Q1 and the maximum to the Q3. So that's what they call a box plot, sometimes called a box and whisker. Of course, the box being the green part here, the whiskers being the min and max on either end. There we go. Now, on the inside, the IQR, realize that this whole part right here represents the middle 50% of the graph. Right, from Q1 to Q3, like 25% to 75%. It's the middle 50%. So you want to look at it that way, either from as the middle 50% or 25% to 75% of all your values are in this box. So if you go up here and you found the middle numbers, they'll all be somewhere between 62 and 79. Then you have the over here, this is going to be 25%, and up here is going to be 25%. And one of your Khan Academies will ask you questions about this. Meaning, if they say like, what percent of United States Supreme Court justices have age that's below Q1, below 62 years old, and you could say 25% because here's 62, it's the first quartile, so below it would be 25%. So just being able to read it. Or you can say what percent is above 62? What percent would be above 62? Well, it'd be the middle 50 plus the 25, so it'd be 75% is above Q1. So just the idea that Q1 is at the 25%, Q2, of course, or the median is at 50%, and Q3 is the 75% mark. So if you're above, how much is above 25%? Well, that'd be 75 to get to 100. How much is below? Well, just 25. And that's the reason we have the box plots, because we can see these percentages. When you just have the numbers written raw, like right here, you can't really see that as well. So the visual helps us understand. And I mentioned yesterday that there's this idea that when the mean is equal to the median, not that you have to find the mean here, but that's called normal. It means the data is normal. Well, if you don't find the mean and all you have are medians, you can visually see it here. Basically, is the box in basically the middle of the mean and min and max. So right here you can see, oh yeah, from here to here is basically the same from here to here. So the box, the middle, 50% is actually in the middle of your graph. That's another way to tell that your data is normal. And when the data becomes normal, you can run all these tests, assume all these things, do all sorts of analysis. If the data is not normal, it becomes more troublesome. The best way to get normal data, if it's not already normal, is to get more data. So if you only have, like, let's say here, 8, if you can jump it up to 50, your data becomes more normal, and then you can do a lot more. As I mentioned before, there's a whole year of statistics if you want to take that class down the road. They go into all the details. And you'll probably learn a lot of things that you never even thought of. As I mentioned before, there's that book on how to lie with statistics, right? And if you know how to calculate things on your own, you know where you can be lied to and deceived when people are doing the statistical analysis, but they're doing it wrong, or they're doing things like, you know, only have like 11 data points, and they're saying, okay, this must be true. 90% of people agree with this. Oh, what's your sample size? Oh, 8. Well, that means 7 out of 8 of them must agree, and they probably picked the 7, so they answer a certain way. But if you want a really accurate information, you probably have to survey, you know, 50 at least, 100, or if it's for that country, you have to survey at least 1,500 people to get an accurate reading. So something that you can probably use again and again and again. Also when you're watching those news stories. Okay. So I'm going to do, let's do one more. There's another one in the back which we don't need to do, but let's do one more here. And the only difference is that here we had an even number, 10. So you saw how we calculate the medians and everything. Down below there's 11. So there's a slight difference because there's an odd number, and you might have that, you know, discrepancy. You want to make sure what to do, you know, when there's an odd number. So we can start by putting them in order correctly. And if that's not done correct, nothing will be right afterwards. So be very careful about that. It's like 53 is the lowest. There, 53. And then No. Well, yeah, when you're doing the plotting, you want to use as much of the graph as possible. So a simplistic solution would be, oh, if I go from 56 to 83, I'll just count by tens. Well, but then you'll be using like 4 of these, 50, 60, 70, 80, 90, or 5 of them, and you'll be using like, just this tiny little bit of the graph. So you want to use as much of this graph as possible without going over. So that's the number you want to choose. 53, what comes after? 66. Yep. And mark them off as you go so you don't double count or forget anything. 75, 78, 80. I'm going to mark these off. Where's 80? Yeah, there's 80. 82. 84. 284 is good. And 92 and 6. There we go. Okay. And then just to make sure, count them off, make sure there's an equal number for each. So since there is 11, there's going to be an exact middle number. In this case, it is 82, because that means there's 5 that are bigger than 82 and 5 that are less than 82, right? So the only difference between this and the first one is that for your Q1 and your Q3, you're not going to use the median. This is what you guys did yesterday. So up here, right, we used all the numbers for the Q1 and Q3. All the original numbers, we used them all when we were finding Q1 and Q3. But when you have an odd number, you don't use that median number in the middle. You only use the ones below it and the ones above it for Q1 and Q3. So the slight difference right there. Of course, since there's 5, it makes it a lot easier to find the Q1 and Q3 when there's an odd number. So odd number data is usually the easier one. You don't have to do any like, okay, what's between these two numbers? Whereas even, you might have to. Okay. So find your range. What's the range here from 53 to 96? 43? All right, so we definitely do not have 43 tick marks here. Now, if you divide that by 2, that's going to be roughly, and round down, that's going to be 21. Do we have 21? So you got to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So we might be able to get away with counting by 2s. And if you're not sure, you could always just count by 3s, and that would make it extra safe there. Does it work by 2s? Okay, so count by 3s. All right. And you don't necessarily have to have your first tick mark be 53, the minimum. It could be 50 or 52. So let's go with 50, and then 53, 56, 59, 62, and so on. So just count all the way up. You can go 296 or maybe a little bit above it to finish it up. Okay. Min 53. Max was 96. First quartile 75. Choose the median. 90.